Do they actually? Yes. No way. I don't like this stuff. Oh, okay, good. This way. You definitely. That was definitely. Wait, is it? This is absolutely wild. Are you getting another paper?
Oh, I get it.
Okay, you guys will need a blank piece of paper, a book, and the handout. So if you missed any of that, please get it all sorted quickly.
This is a new unit, right?
It is a new unit. Miro, need your headphone. Thank you. All right, so we are starting our second unit today, since we took our test last time to finish up Unit 1. So the 30-second explanation of what Unit 2 will be like is we do sections 4.4, 4.5, and 4.6. 3 more sections, just like the first one. 4.4, you're going to see is more of the same. It's still Pythagorean theorem, SOHCAHTOA, unit circle. It's really more of an extension of the first 3 sections than anything. I guess it probably would kind of be nice to just do it with the others, but it would make your first test have even more stuff on it. So for most of you, if you really put in a good effort to study for your test, 4.4 goes pretty smoothly. On the notes here, we'll kind of highlight the stuff that's a little bit different. But the trade-off is we don't spend as long on it. So we'll spend all class talking about what's new and getting through some of the book work, and then ask you to finish up the book work for homework. And then next time I see you guys, which will not be till next Tuesday, the first half of class will be set aside for questions and or studying, and then the second half of class will take the quiz over that. So it's very quick. Then 4.5 and 4.6 are a change of gears. 4.5 and 4.6 are both about graphing. 4.6 we ask you to know what tangent, cotangent, secant, and cosecant graphs look like and be able to tell us some stuff about those graphs. But in 4.5 we talk about the sine and cosine graphs, do a lot of transformations, shift them around, all that kind of stuff, and that's really big on the ACT now. So 4.4, more of the same. 4.5 will go very in-depth, graphing sine and cosine graphs. 4.6, we like to know a little bit about the other graphs, and that makes up Unit 2. So to move on, to try to limit your homework here, let's look at the notes and talk about what is uniquely different in section 4.4. So the first two questions say we have a point on the terminal side of an angle in standard position. Determine the exact 6 trig functions of the angle. So all 6, which we're used to doing. And in just a second, you're going to see sine, cosine, tangent still comes from SOHCAHTOA. And then, of course, if you know sine, cosine, tangent, you can still flip those over to get secant, cosecant, cotangent. Okay, what is different about this question that was not true in unit sections 4.1, 4.2, or 4.3 is there's not a triangle here, and there's not enough information to get a triangle yet. Or at least there's not in the same sense. But if the point is on the terminal side of an angle, remember the terminal side is the side that moves. So let's plot this point. This is -8, -7, and it's on the terminal side of the angle, as opposed to the initial side, which is always on the x-axis. So, you have not needed to plot a point for me in this class, but of course you should be able to do that. And then the next thing that's going to be new is we're going to talk a lot about reference triangles in this section. And a reference triangle, you just take this point on the terminal side of your angle and draw to the x-axis, which gives you a right triangle. Always to the x-axis, never to the y-axis. And then we really know 2 of 3 lengths now. Because if to get to this point I went left 8 and down 7, I can label this as -8 and that as -7. The last thing that you have to know is that we are going to be assuming that we're looking at this angle from the origin here. So plot the point, draw the line to the x-axis so you have what's called a reference triangle. Use the point to get 2 of 3 sides. Everything after that is the same stuff. Pythagorean theorem can get you this side. SOHCAHTOA, opposite over hypotenuse and rationalize. Cosine, adjacent over hypotenuse and rationalize. Tangent, opposite over adjacent. And I'm going over that part quickly, but again, you guys have done this part before. I'm not showing the rationalizing step, but I am rationalizing. That's still expected. Okay, so one more time. Different question in number 2. Different point, but you still gonna plot it right 4 down 6. That's 4 -6. That's the terminal side of your angle, the side that moves, as opposed to the initial side that starts on the positive x-axis. And then all that's new is you take this point, draw to the x-axis to create what's called a reference triangle. Realize to get to this point you went right 4 and down 6. So that's 2 of 3 sides of your right triangle. And then everything after that is stuff that you've been practicing. So not saying that you can't get better at it, you can't maybe get a little bit quicker at it, but the second half of the question should seem very familiar. It's just these first couple steps that are a little bit different. So tangent, I could do sine over cosine and reduce. Flip that over for cotangent. Here, if I did Pythagorean theorem, 52, which is 226, 213. This is 2 square roots of 13. And then you could pair up opposite over hypotenuse. That fraction reduces and rationalizes. Cosine, we could pair up adjacent over hypotenuse. That reduces and rationalizes. And I don't know if you've caught this before. I don't know if I verbalized it, but if you want to know cosecant and you know sine, I know you guys know that you can flip this fraction over, but try to be a little smart about it, because if you flip this over, you're going to have to rationalize and resimplify. Whereas if you flip it over from way back here and reduce to 6 over 2, it's a lot easier. You don't have to rationalize and reduce as much. Same thing with this. You could flip 2 square root of 13 over, rationalize, reduce, and you'll get the same secant answer as me, but you could also just flip it over from back here. So that would be square root of 13 over 2. I'm just reducing the 4 over 2. Okay, so once again, I'm going over the SOHCAHTOA part super fast. I'm blazing over the Pythagorean theorem. I'm skipping over the rationalizing. You'll still get more practice out of the book, but you've seen that before. The part that I need to make sure that we're all on board with is taking this point, how to make this triangle.
Do you have an extra pencil? Mine's all out of lead.
There should be something there. Is there anything in there? No, I don't want to do that. Okay, so before we move on, are you guys okay with where this picture is coming from this point? Because that's what's different about that than what you've seen. Okay. Then, the next thing, we would like you to know which trig functions are positive and negative in each quadrant. So if you don't remember quadrant numbers, you need to relearn those. But here's the long version, and then I'll tell you a much more efficient version. I guess in theory, we could have asked you what trig functions are positive in quadrant 1 on your last test, and you would have had to think about, well, on the unit circle, are the cosine values positive? Yes, because it's going to the right. Are the sine values positive? So if cosine's positive and sine's positive, what would tangent be? Because sine divided by cosine, positive divided by positive is positive. And then if you flip sine over, a positive fraction flipped over is still positive. You flip cosine over, if it is positive, you flip the fraction over, it's still positive. And if tangent's positive, then cotangent's going to be positive, because reciprocal doesn't change signs. So it sounds like everything's positive in quadrant 1. Quadrant 2, you have to go left and up. So sine's still positive, but now cosine's negative. What about tangent? Good, because sine positive divided by negative would be negative. And you can go through the whole thing like that, and there's nothing wrong with that. It's just a little bit kind of taxing. What's much more common for students is to use this acronym. And there's a few ways to say this, but the most common one is all students take calculus in order of the letters. And what do you think that A stands for?
All.
Good, because they're all positive in quadrant 1. I only briefly talked about quadrant 2, but what was positive in quadrant 2? Okay, sine and one more. Cosecant, his reciprocal, because if you flip a fraction over, that doesn't change the sign. So the only two trig functions that are positive in 2 are sine and his reciprocal. What's positive in quadrant 3? and his reciprocal. And then the C, you can probably guess, is for cosine and his reciprocal. So this all students take calculus is a quick visual to quickly tell us what's positive in each quadrant. And of course, if you know what is positive in each quadrant, then you know what is negative in each quadrant as well. So we got a couple book questions that will refer to that. But even outside of those question types, this is a super nice tool to use on the questions that we're doing today. So I didn't say anything about this in questions 1 or 2, but I want you to see how it could help you potentially catch some of your mistakes. In question 1, we had an angle in quadrant 3, and what trig functions are supposed to be positive in quadrant 3? Tangent and his reciprocal, which means that the other ones are supposed to be negative. So if they were not negative, I would know something's wrong. Okay, somebody else. Number 2 was in quadrant 4. What's supposed to be positive in quadrant 4? Okay, cosine's positive, his reciprocal's positive, and everything else. Okay, I didn't do this on purpose, but I did this wrong. Everything else is supposed to be negative. These are supposed to be negative, right?
Oh, yeah.
I honestly didn't do that on purpose. I just went too fast. But that's my point. If you know what's supposed to be positive and negative in each quadrant, it doesn't take 2 seconds to make sure that the right answers are positive and the right answers are negative. And you can literally catch the same mistake that I just made. Honest mistake there. And I think I even started with these because they were the easiest ones. So easy to do. So even if you don't have to use it, sometimes it's still helpful to catch some mistakes. Okay, we've got some other questions in the book that ask you to take a point on a line in a certain quadrant, and then it will be like questions 1 and 2. But to be able to do that, you need to remember how to graph linear lines like this. So if it is in mx plus b format, you need to remember that b is the y-intercept, m is the slope, and you can count rise over run. And that's what that line would look like. The second one's also already in mx plus b, so instantly I know it crosses the y-axis at 0. Use the slope of 1/3 to count up 1, right 3, and 2 points to find a line. So that's all you need. Again, we're not doing the trig here, but there is trig questions that go along with this in the book. It'll say something like, take a point on this line in quadrant 1. So you might say, well, 3, 1 is on there in quadrant 1, and then you work it just like questions 1 and 2 on our notes. You've got a point to go off of. Okay, what if it's not in mx plus b format like this?
Make it xy format.
XXY format.
Sorry, XB format.
XB format.
Whatever you called it earlier, I forgot what it's called.
mx plus b?
MX plus B.
Okay, well, how do I get it to mx plus b?
So you just move the 2x to the other side, and then you multiply by -1.
Okay, so solve for y equals,
2x.
and then you've got it in mx plus b. And you should be able to see the y-intercept gives you 1 point. Use the slope, rise over run to get a second point. And then once again, if it's not in mx plus b format, you could just solve for y equals to make it in mx plus b format. Again, I know I'm going to this part fairly quickly, but you really should remember this from algebra anyway. But we do put one of these on our quiz typically, and if you don't sketch that line correctly, then you don't pick a point where it's supposed to be, and then your answers end up being off. Okay, any questions about graphing the linear lines? A quick review of that. Okay, the whole back page is set aside to talk about reference triangles again, and then something called reference angles. And then we can move over to the practice. So, reference triangle, I kind of spoiled this already on the top of the front page. But let's say we had an angle in quadrant 1, 2, 3, or 4, all the different possibilities. All you have to do to take an angle and get a reference triangle on it, out of it, is take the point and draw to the x-axis, never to the y-axis. Sometimes that's down to the x-axis, sometimes it's up to the x-axis. Draw it perpendicular so that you have a right triangle. We need a right triangle so we can do SOHCAHTOA, Pythagorean theorem. Both of those things only work with right triangles. Now the reference angle is this guy right here. The angle by the origin is always going to be an acute angle. And by definition, it's always positive. Reference angles don't care about direction at all, so we always want them to be positive. So the last part of our notes is getting a little bit of practice in how to figure out how big a reference angle is. That's what we will ask you to do. So the steps that I have set aside are sketch the angle. Usually the original angle is called theta, whereas the reference angle is called theta prime. Not the same angle. So that little designation helps us keep up with which is which. I guess after you sketch the triangle, you need to draw in your reference triangle so that you can see the reference angle. But then what's difficult about these is you have to use your context clues to figure out the size of the reference angles. So I've got 4 examples here, 2 in degrees, 2 in radians, and then I'll have you practice 2 in degrees and then 2 in radians. So to know how big this guy's reference angle is, I need to sketch it. And it doesn't have to be very accurate, but it has to be accurate enough that's in the right quadrant. If you sketch this in quadrant 1 or 3, it's not going to work out. This is what we would call theta, the original angle. If you take this point on the reference, or on the terminal side, and draw to the x-axis, you now have your reference triangle. And then this acute positive angle here, that is the reference angle. Theta prime. And we will be asking you how big that is. So what do you think?
180 minus theta.
This one is 70 degrees. The same thing you said, you just didn't do the arithmetic. So every one of these questions is going to work out differently. You can't just say, well, okay, I do 180 minus the angle given to me. Our context clue was we knew this much of a turn is 180 degrees. And if I don't include all of this stuff, which happens to be 110 degrees, what's left over would be the reference angle. Okay, do that again for this one. Let's see, this would be negative 90, negative 180, negative 270. So negative 285 looks roughly like this. Again, as long as you get it in quadrant 1, that's going to be good enough. Take your point, draw to the x-axis so that you have your reference triangle, and there's now a reference angle. And there's not one way to figure out how big that reference angle is. There's many different ways you could do that. Has anybody got a guess?
75.
60 minus 10.
I think 75 might be too big. What did you say?
I
But the same thing, 360 minus 285.
I think it is 75.
Plus two.
It is 75.
It is 75? Okay. All right. Y'all are better at arithmetic than me. Okay, so if you don't see why that's 75, what you need to do, because sometimes it's more obvious than others, but similar to the last question, we know this is 360 degrees. The amount of that's not the reference angle, I know is 285. I'm not subtracting negative 285 because, again, reference angles are always positive. They don't care about direction. So this amount of turn would be 360, but this much of it, 285, is not the reference triangle. So what's left over must be what the reference angle is. Of course, it's always a little bit easier in degrees. So we also need to be able to do the same thing in radians. So plot the point in the correct quadrant. Draw your reference triangle. Identify your reference angle. And then try to use some of the angles you know around that to figure out how big that positive acute angle has to be in there. So in this one, this is similar to 4 to me. How much is this much of a turn? Okay, but this is in radians, so I want my work in radians. Okay? And how much of this pi is not the reference angle? How much of it is not the reference angle? All of this, which happens to be 3 pi over 4. So this one I know. Take away how much of it's not the reference angle. It should leave behind how much is the reference angle.
4.
Yes, good job.
Mr. Townsend, would we keep it in degrees or keep it as radians?
It needs to be in radians. Generally in math, unless you're told different, if a question is given to you in degrees, the answer is expected in degrees. If it's given to you in radians, it's expected in radians. And we usually put that in the directions too. Yeah.
Could you find it in degrees and then change it back to radians?
Sure. The only thing is you don't always have a calculator. This particular quiz, we don't let you use a calculator, so if you can convert 3 pi over 4 without a calculator, which you should be able to, but it's a little bit harder, and or convert 45 degrees back to pi over 4, which I would hope you would know from the unit circle, but it does add an extra layer. You don't always have a calculator, so. Okay, and then negative 7 pi over 6, one more before I let you try them in 2 different sets. Again, you don't have to be super accurate, but you better do enough to figure out that it lands in quadrant 2. This is what we call theta. After we draw in the reference triangle, this little piece of it is theta prime. That's the reference angle. That's the one we're going to ask you for the size of. So I'm a little more comfortable with radians, so I can tell you pretty quickly that that's going to be pi over 6. How do you know that the answer is not negative pi over 6?
Because the answer is positive.
All right, reference angles don't care about direction, so it's always positive. If you don't see why it's that, you could see that this red angle, this full turn was 7 pi over 6. And if you went back and subtract off all the stuff that's not part of the reference triangle, that would be pi. So take an angle you know, subtract off how much is not the reference angle, and it should leave behind how much is the reference angle. Okay with that? Okay. Then, just very briefly, again, you'll get to try this in the book assignment on a couple questions, but try the 2 degree questions. Make sure there's not something immediately holding you back. We'll check those, and then we'll try the 2 radian questions, and then we'll move on. Again, a good rule of thumb, though, is to know that it has to be acute and it has to be positive. Either one of these answers, if your answer is bigger than 90 degrees or if your answer is negative, There's no chance your answer can be correct. You need to tweak it a little bit. Okay. How did you know what quadrant this was in? Or what quadrant is 215 degrees in? Okay, how did you know that? Okay, so if we know this is 180, it's a little bit more than 180, right? Well, how much more was it than 180? Because that's your reference angle. $35? So as you're sketching that, you're kind of, when you're saying it's a little bit more than 180, how much more it is than 180 is what the answer is. Or you could say this whole turn is 215, take away the amount of it that's not the reference angle, which is 180, and you get the same thing. There's many ways for you to get that answer, but the picture is the most important. If your picture's not, if you try to do it with no picture, good luck to you. I don't think I could do many of these without a picture. I could probably do the next one without a picture, but also if you make your picture incorrect, then it's going to mislead you. Okay, negative 75 would be in quadrant 4, like so. And so here's the reference angle. You might be tempted to say it's negative 75 degrees, but reference angles don't care about direction. That amount of a turn is still 75 degrees. You just didn't need to do any arithmetic there. The angle was the exact same size as the reference angle. Just had to know it was positive. Okay, if you have a question about either of those, please speak up and say. Otherwise, try the 2 radian questions, 10 and 11. I'll give you a little bit more time there since radians are a little bit less familiar.
It's okay that I wear my sunglasses, right?
Yes, sir.
I mean, once that clears up, I don't want you to, but.
Yeah.
Y'all need longer? Okay, 7 pi over 4. Hopefully you didn't spend too long thinking about where that one was. because that is a unit circle angle, so that should make it a little bit quicker. So your reference triangle should look like this. Your answer is this angle in here, and that should end up being pi over 4. How I'm getting pi over 4 is I see if I went all the way around, it would be 2 pi. The amount of that 2 pi that's not the reference angle is all of this, which happens to be 7 pi over 4. And then if you get a common denominator and subtract, the leftover should be the reference angle. Okay with that one? I will also warn that when you do your book assignment, there's like 8 of these questions, and again, you can see that they're pretty quick, but the book says sketch the angle, sketch the reference angle, just like we're doing, but I believe on the quiz we don't make you do the picture. The directions don't say that you have to make a picture, but if you don't do a picture and you're just trying to visualize this in your head, more times than not, it's not going to work out. So always, if you can, make a picture. So this one landed in quadrant 4. I know going all the way around is 2 pi, or in this case negative 2 pi, which is the same thing as negative 6 pi over 3. So negative 7 pi over 3 would be a little bit more, and the how much more is positive pi over 3. That's what you should be aiming for there. Or you could say that angle turned this much, and this much of it was not the reference angle. And that would be the arithmetic way to get to that. But again, you got like 8 of the book assignment questions are like that, so you'll get plenty more practice. But is there any quick or immediate questions? If you know you have a question, there's no sense in waiting. Okay, then as we've done in the past, I will give you some help on the book assignment, but to change it up just a little bit here, I am going to kind of flip it a little bit. So I'm going to set a 10-minute timer here, and so I'd like you to copy the assignment down to that blank piece of paper you got out, do the vocab check, and then try to get a couple more questions done. The first couple are like the first couple in your notes. And then when the 10-minute timer's up, I will let you guys ask questions on ones that you have tried, that you need help with. And so if you don't need help with any, you can ignore me for a moment and then keep on going. Then I'll set another 10-minute timer, and just rinse and repeat, get through as much of it as we can. But what you don't get to practice in class is what I'll need you to do for homework, so you want to get through as much as you can.
Bless you.
Just about 2 more minutes, and I'll see if you have any questions ready. so there's our first 10-minute timer. So I realize you only got a couple questions under your belt, but by the time you wrote down the assignment, hopefully you had time to look at all the vocab, and then maybe question 9B, maybe question 11A. Any of those that you've tried that you want some help on? Yes.
Anyone?
It wants to know sign in terms of X, Y, and R.
But I'm confused where it says R equals square root of X squared plus Y. I have no clue. I need to know that.
If you have a circle centered at the origin, if this is X and this is Y and this is the right triangle and this is R, it's just Pythagorean theorem. Solve for R. But sign in terms of X, Y, and R is Y over R, because when you're talking about the unit circle, sign is Y. Also remember with the vocab check, it's always exactly word for word a page or two before. So if you look at page 288, that little box there has the answers to several of the first few. Okay, any others from the vocab check? Okay, anyone that had time to finish 9B or get far enough in it that you got stuck? Yes? 9B, okay. So if you do not need help with 9B, you don't have to stay with us here. You're welcome to just keep going at your own pace. And if you're not sure, you probably should stick with us. Okay, so here's the original angle. We're going to call theta. Take this point, draw it to the x-axis to get your reference triangle. To get to negative 8, 15, you're going left 8 and up 15. You can do Pythagorean theorem for the third side, but I do think this is a Pythagorean triple. I think 8, 15, 17. Okay. And then the angle that we look from is going to be this reference angle in here. So if you want to know sine of the reference angle, it's going to be opposite over hypotenuse, cosecant to reciprocal. Cosine will be adjacent over hypotenuse, secant's the reciprocal of that, and tangent opposite over adjacent, cotangent, adjacent over opposite. All 6 answers. And then what I suggested to you in your notes, because this only takes me more than 5 seconds to explain it, but if in your head you're thinking about this, all students take calculus, your angles in quadrant 2, the only answers that are supposed to be positive are sine and his reciprocal. So you need to see that those are positive and the other 4 are negative. If that's not true, then you know something's wrong. So. Okay, anybody else that's going to ask about 9B have anything more specific about it? Okay, I think the next one is very similar, but it does have a square root, so it makes you deal with that a little bit. Okay, I'm going to reset, do another 10-minute timer, so same thing. Get as many done as you can. Don't give up on a question too quickly, but also don't stay too long on it. Good idea to be checking your work as you go along. In case something's wrong, it's a good time to get it cleared up. But I will take all the questions you can find in the next 10 minutes. All right, it's been another 10 minutes. So what other questions did you get to that you need some help on? Yeah. Number 5? 25. Okay, 25 tells us sine is 0.6, and I don't like that, so I'm going to change that to a fraction. And our angle is in quadrant 2. So no picture given to us, so probably a good idea to make a picture. Put your angle in quadrant 2 so that it fits that condition. If you know sine is 3/5, then you could label opposite as 3 and hypotenuse is 5. This looks like a Pythagorean triple, so what would this one have to be? 3, 4, 5 triangle. And then it looks like we have all that we need. But I did purposely make a mistake on here because I want to show you how easy it is to do that and how easy it is to catch it if you take my advice here. If you say sine is opposite over hypotenuse, I guess that one was given to me. They didn't really ask for that one, but you start doing all of these. Four of these answers are wrong. So what did I not think about? Right, so the way you could quickly check it is if you're in quadrant 2, all students take calculus. Quadrant 2, the only positive answers you should have is sine and his reciprocal. Everything else is supposed to be negative. So you at least know that you need to go back and reconsider. So here's what's happening here, and you guys need to be aware of this. If you know your Pythagorean triples, 3, 4, 5, that's great. But knowing Pythagorean triples, they have no idea when or if you want to keep up with direction. This 4 is going left 4, so it has to be a negative 4. You're going left, plotting a point, x is negative. Likewise, if you had done Pythagorean theorem is one of the best things you get out of geometry. But Pythagorean theorem is also not smart enough to know that you want to go left that direction. It's just finding a length for you. It's going to tell you this length is 4. You have to be paying attention enough to realize that if it's going left 4 or down 4, you got to make that 4 negative. And as long as you consider that all students take calculus, you will at least have a good opportunity to catch that before you circle your final answer. But I'm guessing at the start here, maybe you just didn't think to change that as a fraction. Okay, anybody else had something to ask about 25 while it's still up? Okay, somebody else have another one ready to go? Okay, let me give you 10 more minutes. Try to get a few more questions under your belt.
Mr. Townsend. Jack says he misses you, the advisory, a whole lot.
Yeah?
Yeah.
I'm sure he'll be okay. I don't think I'll like the advisory last year anyway, so. Alright, it has been another 10 minutes. Okay, so now what do you got? Okay, I heard 33 first. Okay, they want you to take a point on this line in this quadrant. So this is why we practice sketching mx plus b, y-intercept of 0, slope of -1. Now, one mistake that students make on the quiz is they might take this point at 1, -1, but that's not in quadrant 2. You need to backtrack the slope. This could be at like -1, 1. This is a point on this line that's in this quadrant. And as soon as you identify that point, now it's like the first 2 questions on our notes, the first 2 questions in our book. You can draw your reference triangle. You're going left 1, up 1. You could do Pythagorean theorem to find the third side. And we're going to look at this angle by the origin. So sine could be opposite over hypotenuse, but needs to be rationalized. Cosine is adjacent over hypotenuse, needs to be rationalized. Tangent is opposite over adjacent, and flip it for cotangent. So obviously that comes a little bit easier for me because I practice more of these, but it took me about as long as it took me to write down. So you have to graph this line and take any point on it in quadrant 2. So what they're wanting you to see is I picked the very first point, which is what I would think you would do, but if you wanted to, you could pick like -2, 2, and it would change these numbers. But your sine, cosine, and tangent, all this stuff is proportional. So after you simplified your fractions, you would still end up with the same 6 answers. But
I started it and then I got confused.
okay, no problem. And again, just to practice what I preach here, quadrant 2, the only thing supposed to be positive, all students should be sine and its reciprocal. Everything else should be negative. So if that was not true, I would know I had forgot something.
Can you just use the zeta superfunction?
You can if you realize that that would be exactly in the middle of this quadrant, which is the same as 3 pi over 4. Then yeah, you could. But it's not always going to be that way, so. Yeah.
34.
34?
Yeah.
Okay. So same idea. We need to sketch y equals 1/3 x plus 0. Rise over run. And they say take a point from quadrant 3. So don't pick something in quadrant 1. That's not what it's asking you to do. It's wanting you to find a point in quadrant 3 on this line. So if it's going up 1, right 3, the first point, and again, you should be able to pick any point you want to, but the first point would be -3, -1. Make your reference triangle. Realize to get to that point, you're going left 3, down 1. Pythagorean theorem should get you square root of 10 here. And if we're looking from the reference angle, sine is going to be opposite over hypotenuse. That has to be rationalized. Cosine will be adjacent over hypotenuse. Tangent opposite over adjacent. And then the rest should fall into place. Secant could be hypotenuse over adjacent. Cosecant could be hypotenuse over opposite. And then quadrant 3, all students take calculus. The only answers that should be positive in quadrant 3, because that's what the directions told me to be, would be tangent and his reciprocal. So it's good that those are positive, and it's good that the other 4 are negative. Doesn't help me get the right answer, but it would tell me that it's wrong before I moved on. Yeah.
This is a little. Actually, never mind. I don't have a question.
All right. Was that enough? Anybody else that's going to ask about 34 have something more specific there? Again, please, please, please try to make that connection to the second you find a point on that line in this quadrant, it's just like the first couple questions. If you can do the first couple, then you can do this one as well. They're just making you work for that point instead of just telling you the point up front. Okay, somebody else have another one or two? Okay, I can't set a full 10-minute timer here, so let's just do 5 minutes, and I'll try to sneak in another question or two before y'all go.
Can you tell me 19 to 20 is correct?
What is the question asking? When those are both positive, quadrant 1, yes. Where sine is negative and cosine is negative, quadrant 3. Yep.
Good, I did it correctly too.
Thank you. Yeah, I do something similar to that. Since no one's asked this yet, but I usually do like number 20 was this one that you showed me?
Yes, yes, sir. And cosine is smaller than 0. Yep.
I actually do kind of like what you did, but I just make 2 little charts and then say sine is negative. Well, he's positive in these 2, so he's only negative in those 2, so 1 and 2 can't be my answer. It has to be 3 or 4. And cosine's negative, well, he's positive in 1 and 4, so it has to be 2 and 3. So if this is true in 3 and 4, and this is true in 2 and 3, the only quadrant that both of those are true is so that visual sometimes helps. But with your little checks and stuff, you're basically doing the same thing. And rarely you can have more than one quadrant as an answer.
Really? So, would you ever give us a question that with 2?
I think on your test review. But the directions say determine what quadrants, plural. These say what quadrant, so it implies there's only one answer.
Whoever says quadrants, because there's usually 2, can sometimes be 2.
Sure, it could be 2. What if cosine was positive? Where's cosine positive?
All on C. So
So 1 and 4.
Yes.
Okay. Where is secant positive?
We're in the same spot. S and T. Scratch those out.
Okay. So these two are always positive in the same times, right?
Mhm.
Because the reciprocal doesn't change the sign. So if this was a question, you need to say first and fourth. There's really 2 places that that's true.
Gotcha. If you ever give us a question that maybe nothing is true, so like let's say scratch off A and C and S and T.
I guess we could.
Throw that in there.
Why not?
No, it's not.
It's not harder.
Yeah. We just put undefined or
Or
no
just say
quantity.
no solutions. Undefined kind of means like mathematically it doesn't work. If there's just no solutions, you should say no solutions.
Gotcha. Gotcha.
So that timer was only for 5 minutes because I'm going to take any more questions. I have to start getting them in. Any others that you found in those last 5 minutes? No, it's just a unit circle question. Go to 3 pi over 2 on the unit circle. Think about the point there. The point gives you sine and cosine. Use that to find secant. That's all it wants for 39. Okay, so again, it looks like a big book assignment, but once you guys get to about question 39, there's a couple that are just unit circle. 8 of those questions here at the end are just finding the reference angle size, which don't really take a long time unless that's not clicking for you. But between now and next Tuesday, I need you to try the rest of those questions. Utilize the videos on the website to help you with some of your misunderstandings. But when I see you on Tuesday, I'll let you have the whole first half of class to ask questions / study. And then the second half of class will be quiz questions, just like from the book.